Lesson 12, Puzzling It Out, Proving the Triangle Sum Theorem. In this lesson, we'll explain, using pictures, why the sum of the angles in any triangle is 180 degrees. Today, we're going to pull together all the information that we've talked about dealing with angle measures. We've talked about vertical angles, angles that are congruent when we have parallel lines, and we've talked about how there's 180 degrees in a triangle. Let's just start with this warm-up that tells us that point D is on line AC here at the bottom. And we're asked what are some possible angle measures for this angle, this obtuse angle, angle ADB, and for this acute angle, angle BDC. So I can tell that since angle ADB is obtuse, I could just estimate that it might be about 115 degrees. And whatever that angle measure is, I know that this angle measure is going to be the difference between 180 and our larger angle. So if I take 180 and subtract 115, I get 65. And we did that in class the other day. So those are two possible angle measures. I know those will work because they should add up to 180 degrees. So if I ever have two angles that exist on a straight line, I should be able to use the fact that they add up to 180 to piece them together. Let's move on. So there's going to be a lot of angle puzzles today where you're asked to figure out angle measures based on just a little bit of information. Now what we have right here are two intersecting lines. So I bet we're going to be able to use vertical angle measures and the fact that those should be equal. We're asked to click on an angle to reveal its measure and then determine the rest of the angle measures using as few reveals as you can. In other words, I'm going to click on one of these angle measures just to get started. I'm told that's 42 degrees. And I know that this angle measure over here on the left must be the same because these are vertical angles. I'm going to fill that in. So I've got two of the four angles. If I'm stuck, I can click on another angle to reveal. I can click up here to reveal another angle measure, but I don't think I need that. Let me get a pen out here and just show you what I see. I see this straight line, and I know that these two angles together must add up to 180 degrees. I know this is 42 degrees, so if I subtract 42 from 180, I should be able to get that other angle. So 180 minus 42 is going to be 138. And if that one's 138, then the other one's 138 as well, because these two are vertical angles. So that's how we're going to do these. Just start with a little bit of information and use what we know to figure out everything else. Let's check my work. So far, so good. Great. Let's move on to the next one. This one deals with parallel lines. You'll remember that if I have parallel lines, I'm going to highlight the parallel lines here, and a transversal, that leads to some other congruent angles that have equal measures. Here's my transversal line. Let's go ahead and click on one angle to reveal its measure and see if we can figure out all the others. I'm going to click on this one. It's 45 degrees. Now, if I'm just focused on these two lines at the top, they intersect each other, so I have two vertical angles. If this is 45 degrees, then I know the one on the other side of that intersection is also 45 degrees. Now I'm going to move to the fact that I have two parallel lines. Maybe you'll remember from one of our lessons, we could take an angle. Well, you know what? We'll go back to our original angle. And imagine that we're translating it right down this green transversal line. And it would land right here. So I bet that this angle that's on the other parallel line on the bottom is also 45 degrees. And I'm going to return to the fact that I have 180 degrees here and use that information along with the fact that this is 45 degrees to find out that last angle measure. I'll just subtract 45 from 180 and get 135. Oops. Let me fill that in and see if we're right. So this time we had vertical angles and we dealt with the fact that we had parallel lines. Let's look at this one. This one involves a triangle and some parallel lines. No vertical angles this time, but we still have a lot of tools at our disposal. So I am going to highlight my parallel lines again. And we really have two transversals this time. I'm going to highlight them in two different colors. Sometimes that helps me to see what angles I should be looking at. Here's my second transversal line. Okay, so let's click on one angle and find all the others. I'm going to click on this one. Now, as I'm looking at these two green parallel lines and this orange line that makes up the other side of this 38-degree angle, if I follow that orange line down to the other green line, which is parallel, I see another angle that looks like it's about the same size as that 38-degree one. In fact, maybe you'll remember I could rotate this and fit it on top of this angle. That only works because those are parallel lines and they're both connected to that orange transversal. So I know this is 38 degrees and this is 38 degrees. Now this time, I'm going to have to reveal another angle measure. I think I could figure out what this big angle was, but since it's split into two pieces, I'm going to need another reveal. All right, so now we know that this is 82 degrees. If I know this is 82 degrees, and I know that all three of these should form a straight line, 38 plus 82 plus something should add up to 180 degrees. So let me start with 180 degrees. Actually, let me add these two together. 38 plus 82 should give me 120. And then I can take that and subtract it from 180. So this angle must be 60 degrees. I also want to point out, let me do this in a different color, there was another way we could have found that. You'll see that I have two angles in a triangle. So instead of looking at this as a straight line, I could have gone through the same procedure, added up 38 and 82 and subtracted from 180, and that would still give me 60. But I could look at it from the triangle point of view instead of the straight line point of view. And that should work because this angle and this angle should both be 60 degrees. They're on opposite sides of this transversal and made up of those two parallel lines. Let me erase this mess and see if we got them right. I needed two reveals this time. But I was still able to figure out everything else. The next two slides focus on a triangle. We're asked to make a claim imagining that the two lines stay parallel, but I can drag points A, B, and C to make any triangle in the world. So if I could drag A, B, and C anywhere I wanted, and these two lines stayed parallel, I'm going to click two angles that I think are always going to be congruent no matter where I drag those points to. And I'm going to choose these two. Because if these two lines are parallel, then these two angles that are connected by this transversal line here are always going to be congruent. That's what I believe. That's my claim. The two angles made of the transversal and the parallel lines will always be congruent, this one and that one. Let's go ahead and test my claim. I said that those two would be congruent, and I'm going to move these points around, but the two lines are going to remain parallel. Let's look at what happens to those angles. It looks like they still remain the same. And what if I bring this C real close? Looks like they still are equal to each other. What if I move A? Let's see what that does. Nope, those two angles are still equal to each other. No matter what I do with A, B, and C, as long as those two lines remain parallel, those angles that I marked are going to remain congruent. And this brings us to one of the proofs of proving that a triangle has 180 degrees. Fabiana claims that if you tell her the value of x, which is right here, and y, which is right here, she can figure out the value of z. Now, I think that's pretty obvious, because if she knows two angles in a triangle, she should be able to figure out the third. I don't think I need the sketch tool to say that, but I believe Fabiana. Okay. We actually split this lesson into 2 days, with the first day being done right about now, and the second day starting with angle puzzle number 4. Let's talk through the next few angle puzzles, but in class we did this on a sheet of paper just so it was easier to mark things. So I'm going to kind of lead you through how we can figure out all these angle measures based on just a few angles revealed. So we'll click on an angle to reveal its measure to get started, and then use all of the things that we know to figure out all the other angles. I am going to start with this angle here. We're told it's 49 degrees. Let me show you what my thinking is. Let's use blue. I'm looking at the fact that I have a triangle. I know the measure of one angle. I know the measure of this right angle. So I should be able to find the measure of this third angle. So let me start by adding together the two angles I know, 49 plus 90. So that's going to be 139. And then I'm going to subtract that from 180 to find that third angle measure. So that's 139. So that should be this third triangle measure, 41. So that time I just used the fact that I had this blue triangle. Let me erase that and see where we can go now. Well, I think I might be stuck. I might need another thing revealed because I don't have another angle to add in for these other triangles. So I'm going to reveal one more. And this time I'm going to look at a different triangle. Let's look at this triangle right here. And again, I have two of the angle measures. I have 105 and 41. And I can find this third one. Let me add up 105 and 41. And then subtract that from 180. Oops. So it looks like this angle measure in this orange triangle is 34 degrees. Clear that. The rest of what we need to look at, I'm going to use different observations. Let's find this angle right here, knowing that from here to here is a straight line, and that should be 180 degrees. Well, if all the way around, or all the way from one side to the other is 180, and I know the measure of one of these is 105, then I should be able to subtract to find the rest of that straight angle. It should be 75. And there's two different ways I can find this last angle. One of those ways, let me erase what we have here. One of those ways would be to look at this yellow triangle and treat it like the other ones we've done. Add the two angles I know, 49 and 75, and subtract from 180. Or the other option that I have is to look at the fact that we have a right angle here. And I know that 34 plus something should add up to 90. But I think I'm going to stick with the fact that I have a triangle, since that's something that we learned and we've been practicing. Let's go back to this triangle and use that same skill one more time. I'm going to add 49 and 75. And then subtract that value from 180. There's 180 degrees in a triangle. That leaves me with 56 degrees. Let's see how we did. We used a lot of triangle information, but we also used the fact that these two angles, 75 and 105, should add up to 180. All right, we did a great job. Let's look at this next puzzle. Whew, there's a lot going on here. We have two parallel lines, and we have two different transversals. I'm going to try and concentrate on one at a time. Let's look at my parallel lines. And then my first transversal, which I'm going to highlight in purple here. Ooh-wee. So I've got to start somewhere. I think I'm going to start with this little angle. I think I'm going to start with this angle right here. Whew. So that's 66 degrees. I don't know if I should have started with that one, but that's what I need to do. Well, this gets more complicated because I don't have anything that'll take me straight from this angle, which I can see is acute, to this angle, which I see is obtuse. What I can do is translate this. Let me see if I can draw this. Translate this angle down to this one that's not marked, but I know that's 66 degrees. I know it's congruent to the one above it. So if that's 66 degrees, I should be able to figure out this, that these two should add up to 180. So I'm just going to subtract 66 from 180, since those two angles make a straight line. So that's going to be, it does not look right, 114, that's better. So that's 114 degrees. I'll fill that in. So I had to kind of mentally fill in an angle that wasn't marked by Desmos, but I could still use this to find 114 degrees. All right, where else can I go from here? Not very far, because there's no other angles that are connected to these two parallel lines. So let's reveal another one here. I'm going to reveal this one. Oops. This time I'm going to look at this parallel line, and this transversal. Okay. This angle and this angle should be congruent. I should be able to rotate that right around. They're both obtuse. I'm going to say both of them are 124. And that leaves me with some difficult information here. These angles at the bottom don't have anything to do with the parallel lines, but they do form a little triangle. And that's what I'm going to use to move forward here. All right. Let's see if I can make my pen a little bit smaller. So if this is 124, then this angle has to finish out another 180 degrees. 180 minus 124 is going to be 56. That's 56. And I found earlier that this was 66. So let me write this in. We'll do it in blue. If that's 66 and this is 56, I should be able to find this. Let's try it. Should be able to add 56 and 66. That gives me 122. And then subtract that from 180, which gives me 58. Hope that's right. So 58 degrees is this third angle in the triangle in the middle. Go ahead and try and fill that in. It's 58. I don't want to erase too much because I might need a little bit more. Nope, I don't think I do. I'm going to go ahead and erase this. So there was that triangle in the middle that I pieced together. These get harder and harder. And then the last thing I need, perfect. These two make a straight line. I'm just going to make sure that this angle and this angle add up to 180. Let's finish this off. So I know that 180 minus 58 should give me this bigger angle here. Let's see how we did. Wow, so that time we used lots of information about parallel lines. We actually did we use vertical angles? I don't know if we did. Maybe we didn't. And we used this triangle in the middle, along with the fact that in a straight line we have 180 degrees. Now, let's take a look at the next one. So this one's probably going to be one of our most difficult ones. Let's take a look. I think we're going to go cross-eyed when we're done with this one, but we can do it. Is it possible to determine all of the angle measures with the given information? Use the sketch tool if it helps you with your thinking. The arrowheads indicate lots of parallel lines. Oh my gosh, I'm not going to try to draw all the parallel lines, but I am going to note which lines are parallel. So I have those two lines that are parallel. They each have three little arrowheads there. We have these two lines that are parallel. And on the top and bottom, we have those two lines that are parallel. We're going to use all that and a bunch of triangles to figure things out. Let's see what we can do. So let's start with a smaller pen and the two red parallel lines along with this transversal. So I know this angle measure at the bottom is 51 degrees. So if I follow that transversal up here, I know that this angle will be 51 degrees. So let me just write that in here. This is going to be hard to fit all in. Okay, so that one's 51 degrees. I can use the same kind of reasoning with this 101 degrees that they gave me. If I look at this parallel line on the top and the same red parallel line on the bottom, and I follow this 101 degrees down this transversal, I can see that this angle would be 101 degrees. We're on our way. I'm gonna, let's see. Feel like I have to erase some things just so I can see what I'm doing. So far we've got 51 degrees at the top, 101 degrees at the bottom. And if we look at this triangle here, I think we can find this missing little tiny angle up here. These bottom two angles are 101 and 51. So 180 minus 152 would be 28. Okay. So this little angle right here is 28. I know that because I know the three of these together have to add up to 180 degrees in that line, or add up to 180 degrees in that triangle. All right, what else can we do now? I'm going to look at this 101 degree angle and this angle here, angle E. I know that I have two parallel lines and this transversal. So imagine taking 101 degrees and sliding it from this parallel line right down here to that parallel line. So this is also 101 degrees. And if I know that this is 28 degrees, and I have these two parallel lines on the left and right here, then I can slide that 28 degrees right down here and flip it over to this side of the transversal. That's going to be 28 degrees. All right, so I think I have everything in this triangle, everything in this triangle. And I bet this last triangle is not going to be too bad. So I'm looking at angle D here. This line is parallel to this line. And I already know that this is 51 degrees. It's made up of a transversal and one of those two parallel lines. I could just slide it right up here. This is 51 degrees here. And if I know this is 51 and this is 101, if I add those together and subtract from 180, I get 28 degrees again. So I was able to find all of those angle measures just given a couple. So that's the last puzzle that you're going to do, but you can see how all the information about triangles, parallel lines, and straight angles all comes together. We'll take a few quick guided notes. I know this is a long lesson, but remember we did it in 2 days in class. So let's switch in your notebook to the notes. So let's start with what our goal is. And we should be able at this point to explain why the sum of the angles in a triangle is equal to 180 degrees. Explain why the sum of the angles in any triangle equals 180 degrees. So we're going to use parallel lines to prove that. We're going to go ahead and look at this figure. I'm going to actually mark it so that we can see the two parallel lines. And I'm going to mark a couple of transversals here. Let's start with this transversal line here. Knowing what we know about parallel lines, if I know that the measure of this angle, I'm going to make it in pink, if this angle is x degrees, I know that this angle is going to be the same. I could just rotate it right around and it would be this angle. So this is x degrees. Let's get a different color and look at this other transversal. It goes from the two parallel lines, but going in this direction. And this time, you can look at this angle measure that's made up of the blue parallel line and the purple transversal. Blue parallel line, purple transversal. You could rotate that right around with rigid transformations. And that angle measure would be the same as this one, z. So now that all of those are labeled, I should be able to piece together why this triangle has angle measures of 180 degrees. Let me scooch down to the bottom here. That's our summary question. How does this diagram show that the angles in a triangle add up to 180 degrees? Well, in the line, in this line at the top, I know that x plus y plus z has to equal 180. And I know that angle A here at the bottom and angle C here at the bottom are also congruent or equal measure to x and z. Since angle, I have to call it angle BAC. That middle letter is the vertex. Since BAC is congruent, I'm going to use the symbol, to x, and angle BCA is congruent to this angle up here, angle Z, then I'm still saying x plus y plus z is 180. Then x plus y plus z in the triangle must also equal 180 degrees. And that's how we prove that a triangle has 180 degrees, by relating it to the degrees that add up to a straight line, or the angle measures that add up to a straight line. So in this very long lesson on proving the triangle sum theorem, we explained why the sum of the angles in any triangle is 180 degrees, and marshaled all of our knowledge about angle measures and their relation to each other to solve a bunch of angle measure puzzles.